Hi and welcome. My name is Dennis and I'm a developer advocate at Amazon Web Services. In this stream, I'm going to build an application on AWS live on stream. So expect a lot of learnings to do for you, but also for myself. We will dive into the documentation. We will have a look at various different services. And if this is what you want to learn, this is the right place for you. So I'm starting the stream today with an existing application that we built throughout the last couple of sessions. This is the fourth session, and you can find the links below to the other sessions in the show. I'm going to put them in the show notes right after the stream. So thank you everyone for joining. Let me have a look at the comments. Yes, we also already have a few people. Sasha, thanks for joining. Shadi, it's nice to see you. Milad, thanks for joining again. We had just been talking on LinkedIn earlier today. It's good to see you all again. And just real quick, what we are going to do today mostly is build a Lambda function using the AWS CDK and deploy it into our overall application stack. We will also be using the local execution environment inside of our IDE to test our Lambda function. So we don't always have to deploy it into AWS just to be able to test that. What I'm using as an IDE is Cloud9, which is an integrated IDE that can be used via the web browser inside of AWS. Hey, Jordan, nice to see you. As I can see, there are already a few people, and I would say let's just start. Just real quick to recap what we are, let me see, let me pull up my screen. Hey, Locust Coding, nice to meet you, nice to see you. So right here, you can see my IDE, but I'm not going to use that now. I'm just going to use that as a canvas for some drawing. So what we did is we started building an application that processes a file whenever something is uploaded into an S3 bucket. So let's see. We do have an. I need to make sure that drawing works. Yes, it does. Okay, so we do have an S3 bucket. This is our data bucket. And new files are going to be uploaded into this bucket. The actual files that we're uploading are, what I'm going to do with the application is really work with my YouTube statistics. So all the stats that I have on this stream and on other videos on my YouTube channel, I want to work with them. Whenever I get new stats, I want to upload them as a CSV into an S3 bucket. And once that's done, this should automatically trigger an event. And this event should then kick off a process and a step function state machine. Let me write that down here. Step functions. This should kick off a step function state machine, which then decides on the type of the file, on the name of the file, and different other things will decide what to do. And in here, we currently have a placeholder. So this state machine, right now it isn't doing anything. It's just, I have a choice in there and I will show you what that is, but it doesn't do anything yet. And today we want to replace this placeholder with an actual Lambda function. So that we do have some actual business logic that we have an actual function inside of our step function state machine. And this is what we're going to do today. And for everybody who just joined, my name is Dennis. I'm a developer advocate with Amazon Web Services. And this series really is to just follow along with me building an application using the AWS CDK, the Cloud Development Kit, with Python, which is new to me. So I didn't do that before. I didn't use the CDK with Python. And I'm not, to be honest, I'm not really good with Python. I've got a background in C# and Java development. But what I'm doing here really is for me to learn how things work and play together, and also for you to learn while I learn, and maybe share my thoughts and how I approach different things. So cool. Let me just delete the drawing. Here we go. Okay. So everybody in the chat, if you have any questions, please let me know. If you're watching this after the stream, if you have any questions, please put them down in the comments and I will make sure to answer as much as I possibly can. Okay, cool. So what we do have right now is right here. We're in the Cloud9. Hey, Edwin, nice to see you. We're in the Cloud9 development environment. And in here, we do have our video stats stack. And just real quick, in CDK, the way we organize things in CDK, so CDK, which stands for Cloud Development Kit, which is basically programming your infrastructure as code. And inside of CDK, we do have apps. Oh, come on. We do have apps. So the outer container is an app. And inside of the app, we can have one or multiple stacks. And in our case, we have only one. And inside the stack, again, we have a number of constructs that basically deploy our specific resources. And what you can see here, this is our stack. And inside of this stack, you can see it's called Video Stats Stack. And it inherits from CDK stack, from this stack class. And what it has is it has a bucket, our data bucket. It has, and this is very important for the bucket, it has a CloudTrail trail, so something that monitors the bucket so that whenever something happens inside the bucket, whenever somebody uploads a file, that this is being monitored. Then we have down here, we have a event rule, the put object event rule. So this is a rule that fires whenever something is uploaded into the bucket. And finally, we have our state machine, which is a AWS step function state machine. And this state machine then does the actual processing of the file. And all this has been deployed into AWS. Let's have a look real quick. I can just do CDK Diff to see if there are any differences to the status of the application. Oh, in the cloud, I'll deal with that in a second. So CDK Diff really helps us understand the status, the state in the cloud versus the state as declared in the current configuration of our CDK stack. What I need to do here, because I'm using Python, I need to first cd into the directory. And second, I need to source my virtual environment real quick. So bin activate. Here we go. So now if I say CDK diff, there should be no difference because it didn't change anything since last time. So you can see in the stack, video stat stack, there were no differences. Now let's have a look at the state machine real quick. And I'm going to do that through the AWS management console, but I'm also going to show you how you can have a look at that using the Cloud9 environment or pretty much every IDE if it has an AWS toolkit like Visual Studio Code, Visual Studio, or IntelliJ, and a couple of others. They have the AWS toolkit, and what I'm showing you here in a minute, you can do with those as well. But first, let's go directly into the AWS management consoles and search for step functions. Let's have a look at the specific step function that we have. So this is our process new file. Let's go back to the code real quick. Yeah, that's the name, process new file. So this is our function. And I'm going to open this. And inside of this function, we do have our function definition. And what you can see here on the left side, that's just the JSON of the function definition, but I would like you to focus on the right side over here, because this is a visualization of the workflow or the flow of our state machine. We will start here. So whenever the function gets triggered, we'll start here. The first thing we have is a dispatch file task, and this is a choice. And this choice will decide based on the name of the file if it should be sent through this here, through process YouTube file. So if it's a YouTube file, it should be processed here. And if it isn't, it just doesn't do anything. So both of those just end up here. File upload processing succeeded. If it's not a YouTube file, nothing happens. If it's a YouTube file, it should be processed. Let's have a look at the dispatch file definition real quick. Dispatch file, you can see on this side, dispatch file is of type choice, and it just looks at the message that's being sent, the event, and the event should contain an ARN, an Amazon resource name, and if this contains YouTube, then we will assume that it's a YouTube file, and it will send it to process YouTube file. Otherwise, so the default, it will just send it to file processing, file upload processing succeeded. The other thing here, the process YouTube file. This right now, if we look down here, process YouTube file, this is just a task of type pass, which means it's only a placeholder. So all it does is take the input and passes it through the output. What we want to do today is replace this with an actual Lambda function. We don't have that yet, and that's what we're going to build. But just real quick, I'm going to show you how you can have a look at this inside of the AWS Cloud 9 IDE and similar in Visual Studio Code or IntelliJ or other IDEs. Let's have a look here. If I click on AWS, I open up the navigation for the AWS Toolkit. And we can see I'm in the region Frankfurt. And inside of this region, I have a number of things, including step functions. And once I open this, it failed to load resources. So why is that? Okay, because the token expired. Now, let's reload. I'm not entirely sure how to reload the token here. I'm just going to reload the page real quick. I'm just going to reload the page. And now it's connecting again. And now the token should be, we should have a new token. And here you can see we've got our step functions, process new file function. And when I open that, when I download the definition, I need to download the definition. And I'll just save it here for now. This is my definition. And now I should be able to render the graph. Let's check it out down here. You can see we've got our graph. So this is up here. This is just the JSON definition of the state machine. And down here we have the graph. So what you need to do is go to step functions, download the definition, or we can even just from here directly render the graph. So I don't even need to download that. Okay, cool. So that works. I'm just going to remove the file that I've just downloaded. So as I said, what we want to do is we want to add a Lambda function. And to be able to add the Lambda function, we will first need to create it as part of our stack. And I'm going to do that down here. And for that, I'm going to use, inside of CDK, I'm going to import, let me see real quick. I'm going to import AWS Lambda as Lambda. And I need to give it an underscore here because Lambda is a reserved word in Python. So I'm just going to put the underscore here. And with this, I'm importing AWS Lambda. What I also need to do is add this to our requirements text. So I'm going to add AWS CDK .aws Lambda. Let's do a quick pip install our requirements text just to install the dependencies. We have an error. Oh, I did delete the README file. Video stats setup py. Here we go. I did something outside. I don't want to use that. Because I deleted the default README. Now it's complaining. See, let me see. Here, it's using all that. Okay, all right. So now it should work. Okay, now it works. Now it installs all the dependencies. Video stats has requirement AWS Core 128. You'll have 132, which is incompatible. For now, I think it should work. I'm gonna leave it at that. If it makes any trouble, I'm gonna fix it. All right. So we're importing AWS Lambda, and down here I can basically say my function, also my Lambda function, is Lambda, and now we need to have a look at how to create a Lambda function using the AWS CDK. For that, let's go to the AWS CDK Python reference. And once we're in there, and chat, if you have any questions, please let me know. Once we're in there, just let's go down to AWS Lambda. Where is it? IKL. Here we go. So that's AWS Lambda. And in the package overview, we should be able to see how to actually use that construct. So we can use function. As always, we give it the scope, which is the stack. It's part of a stack. We give it a name. Then we need the runtime, the handler, and then we need some code. So this is what we need. In here, let's say Lambda function. It needs the scope, which in this case is self because we are inside of our stack. Give it a name. I'll just call it Lambda function for now. I'll give it a better name in a second. And then what we also need is our runtime. And the runtime, again, should be one of the available runtimes. Let's have a look at the function down here. Function. So the runtime should be of type runtime, and we do have a ton. We have .NET Core, a couple of numbers. We have from image, Go, Java, Node.js, but I'm looking for Python. And what I want to use is Python 3.7. We can also use Python 3.9. I'm going to use this one. So runtime equals lambda dot runtime. This one. The next, give me a second. In the wrong window. Here we go. So the next thing we need, in addition to the runtime, is, let's go back. The next thing is we need a handler, and we need the code. And if I go back to the overview, the handler basically tells the runtime environment, the Lambda runtime environment, which function inside of which file. I'm just going to use this one here and rename it to what do we want to call the function? We're processing a YouTube file. So let's call it process YouTube file. And inside of that, we want to call the handler method. We don't have that yet, but I'm going to build it in a second. I'm going to rename the whole function resource. Just call it process can't type. YouTube. Come on. Process YouTube file. I'll call it YouTube statistics. Process YouTube statistics, and I'll call that as well. Okay, so, and the next thing we need, and this is pretty much everything we need to be able to deploy a Lambda function, is we need to use the actual or we need to add the actual function code. And for this we're going to use something that's called the asset system inside of CDK. So we can basically say we want our code from an asset which is inside of a path. So over here, I can simply say lambda.code.from asset. And here, I can just give it a path. And the path in my case, let's see, what are we going to do? Hey, Jonathan, good to see you. Thanks for joining. We're in the middle of starting to deploy a Lambda function into our stack. And later we're going to add this Lambda function to the step functions, to a step function state machine. But right now, I need to add the actual asset to the function construct. And for that, I'm going to add a new file, a new folder. Let's call it Lambda. Let's just call it Lambda. And inside of Lambda, I'm going to create a new file, and I'll give it this name. .py, because it's a Python file. And I'm not screen share. Oh, thanks for saying that. I wasn't aware. Nobody told me. So in here, thanks. In here, we do have basically our construct. In the construct, we're using the Lambda Runtime Python 3.9. We're defining a handler, and the handler will be inside of this file. So we have the Lambda directory, and all I can do here is simply say, get the code from the asset inside this directory. So what it's going to do is when I deploy this, it will look into this folder, bundle everything that's in there, and deploy it as a Lambda function. Right now, the function doesn't do anything. It's an empty file. And I'm just going to add a handler, which takes an event and a context, and it returns. I'll just let it return the event. There we go. So that's all we have for now. Let me try just doing a CDK diff and see if everything works. All right, so let's have a look at the actual diff. It's going to do some changes. It will add a number of permissions for the Lambda function, because every Lambda function needs an execution role. A Lambda function in itself can't do anything on AWS, just like everything. A system, a service, or a person cannot do anything on AWS except you give it certain permissions. And for the Lambda function to be able to do anything in AWS, including writing logs, it needs the permissions to do that. And the way it gets those permissions is through the execution role. And this here will be our execution role. And the Lambda service will be allowed to assume this role. This is a permission change. And we also have the role itself, and it will be called service role AWS Lambda basic execution role. And that's all we have. And you can see down here, it's going to add a few things, and it's going to add the role and the function. These are the most important things. So what I'm going to do now is really try and deploy this function. And before I do that, I'll go in here and go to the Lambda service console. Let's have a look if we already have a function. And as you can see, there are no functions available right now. Once I say CDK deploy, this should try and deploy the function. It's first going to ask me, because I have some permission changes, if I really want to deploy the permission changes. This is a security mechanism. I want to deploy the changes. And now what it's telling me is that the toolkit stack hasn't been deployed. Now, what is the CDK toolkit stack? Just real quick. If we go back here, what CDK is doing, it goes into that directory, bundles the files in here, compresses them into a zip, and then uploads them. But it cannot deploy it directly into Lambda. It needs to upload the file into an S3 bucket, into a staging bucket. And then it's going to deploy it from the staging bucket into Lambda, into the Lambda runtime environment. So what we need is a staging bucket. And to set that up, we can really just simply say, simply install the toolkit stack. And we can do that by just copying this and running it. So what that does is it deploys a new stack called CDK Toolkit. This is also a CDK stack, but that is predefined. So it's creating the stack, it's creating a staging bucket, and it's creating a number of permissions and things that are needed just to make sure that then CDK can upload artifacts into the staging bucket so that they then can be deployed into AWS. I hope that makes sense. So let's see, it's still deploying the staging bucket, and it's deploying a staging bucket policy, permissions for the bucket. And that's it. So we're done with the staging bucket. I'm going to clear this real quick. And now I'm going to execute CDK deploy once again. And again, it's going to ask me if I want to deploy the permission changes. Yes, I do. And now you can see it's publishing something. And this actually is our Lambda function. Hey, Alfredo, good to see you. This is our Lambda function. It is updating that. And while it's doing that, we can go into the S3 console real quick and have a look at the staging bucket that has just been created by the CDK toolkit. So this is our staging bucket, the CDK toolkit staging bucket. Let's open it. It has an assets folder. Sorry. And inside of the assets folder, it has a zip file. And this zip file actually contains the Lambda function. So let me see if I can open this. No, of course it has access denied because the permissions are properly set. But if I download this file and open it with the archive utility, and now I've got it right here, and I'm going to open it with, I'm going to open it just with the text editor real quick. And as you can see in here, this is exactly the function code that I deployed. It doesn't do anything except just passing the event, but it's the function. I'm not going to need that. I'm not going to need it. And it should have been done. So everything has been deployed. And if I go back to Lambda, we should see that our function has actually been deployed. Video stat stack process YouTube statistics. And the package type is a zip file. The runtime is Python 3.9, just as we defined it in our code. Now, let me have a look at the questions in the chat. So, Alfredo, so I use a combination of the AWS console and also the AWS CDK. Yes, in this stream, I do to show you everything. But what I'm actually doing is I'm deploying everything using the AWS CDK and just look into the console and have a look at the actual resources that have been deployed. So in this case, we just deployed a new Lambda function, which is empty, which doesn't do really much, but we've just deployed this Lambda function. And in here, we made sure that it actually exists. And once I open it, it should contain the same piece of code right here that you can see right here. We have our handler and we have an event. And inside of the Lambda console, we can also test this Lambda function. So let's do that real quick. For this, we need to set up a test event. I'm just going to create an empty one. Just leave this as it is. And I'm going to create the test event. So now when I test the Lambda function inside of the Lambda console, I got my response with just the event that I sent. So this is my file. It takes the event and the context, and it just returns the event. And the execution results just have these events. Now, I tested this in the Lambda console, but how can I test my Lambda function locally without having to deploy it every time and test it? I'm going to show you how you can do that using the AWS Toolkit inside of Cloud9, as well as other IDEs like IntelliJ or Visual Studio Code or other ones. Let's have a look. Right here, you can see we have our Lambda function. Still, it's very simple. It doesn't do anything except just passing the event. So what we can do here is add a debug configuration. And to do that, I'm going to use Python 3.9 because that's the runtime that I'm using. And now let's have a look at the debug configuration. This is our debug configuration. It has it's just video stats, Lambda, process, YouTube statistics handler. I want to edit that. And now let's have a look. This is the configuration, this one. What it does, it invokes the target, the code, project root. It has the Lambda handler. It has a number of things here like runtime, payload, and environment variables. And now inside of the payload, I can set the actual test event that I want to use when I test it locally. So I'm just going to call this test attribute test value. There we go. I'll come to your question in just a second, Alfredo. So what I'm doing here, I'll just add a payload to my test configuration. I'm going to save this. Going to make sure this one is selected. And now I'm going to run the Lambda function. So it should take my test payload and just return it on the other side. Let's run it. So down here, you can say it's creating an image. It's creating a local Docker image to deploy the Lambda function and then invoke the Lambda function. And the first invocation takes some time because it has to create the image and deploy the image. And we can go back up and have a look at what it said up here. So it's building, you can see here, it's fetching a public Docker container image for Python 3.9 for x86, because that's the architecture that I'm using on this machine. Let's go back down. All the way. Here we go. Okay, so we failed to execute script main. Let's have a look. Now, what happened here? Container doesn't exist, cannot get logs for. Oh, okay. So we'll get into that in a second. Just real quick for your question. If you use an older Python version, would that affect the runtime? Yes, it would. You always have to define the actual runtime that you are using as part of your function definition. So I could use 3.7, or I could even use 2 point something. But in that case, I would also have to use the respective runtime to test it locally. So I'm not going to change that. What we have here is an issue down here. We have an issue with our Cloud9 instance, because by default, a Cloud9 instance is only deployed with 10 gigabytes of disk space. And because we're creating a Docker container and we're doing a lot of those things, we are running out of disk space. And to mitigate that, what I need to do is to increase the disk space in my Cloud9 environment. So I'm going to close that real quick. And we can go to EC2 over here. I'll just open a new tab. If we go to EC2, you can see we've got our Cloud9 instance, and this instance has an EBS device attached, and this device down here has only 10 gigabyte. And this is way too small if you want to run Docker containers and everything. So what I need to do is open this EBS volume. Then I need to modify it. And this is something that I can do while the instance is running. I don't have to shut down the instance. I can just do it here. I'll say modify volume. And down here, just to be sure, let's give it 50 gigabytes. So now I'm going to modify the volume. Oh, I actually lost my session. Let me log in real quick. So here we go. Let's do that again. It's still 10 gigabyte. Let's go in there. Modify 50 gigabytes. Modify. Here we go. All right. So it is right now in the process of being modified. It's still available. So our Cloud9 instance still runs, but the EBS storage volume in the background is being resized. It's being resized. Let's reload this. It's in use now. It's optimizing. That will take some time because the drive has been modified. However, while that's happening, what I'm going to do is find out how I can increase the size on the EC2 instance, because from the perspective of the EC2 instance, the hard drive is still at 10 gigabytes. So I need to tell the instance that the size has changed. So how am I going to do that? Resize EBS volume on the fly. Let's see. Right, we need to extend the Linux file system. So we have resized the volume, or we're still in the process of resizing the volume. It's still optimizing. Now, what we now need to do is let's have a look. DFHT. Let's just try that. DF-HT. And this is telling us that this is our drive, that this one is still at 10 gigabyte. And actually 8.7 gigabytes are used and we're running out of space. So the next thing is what we need to do is to check whether the volume has a partition that must be extended, use the lsblock command to display information about the NVMe block devices attached. So we're going to do that. Let's have a look. Block. So it's telling me here the drive itself is at 50 gigabytes, but the partition that we're using is only using 10 gigabytes. So we need to extend the partition. And to do that, we need to do this sudo grow part, and then we need to give it the name of the partition. So for volumes that have a partition, such as the root volume, use the grow part command to extend the partition. So let's see. We need to do sudo grow part, sudo grow part for grow partition, and we want to grow xvda. Let's have a look. We want to grow xvda, and we want to grow the partition 1. Let's see if that works. Okay, so I need to do this, right? Let me see. Let me see real quick. Grow part. Notice that there's a space. Which one is? Let me have a look. That's the NVMe 01N. Oh, I need to add dev. I'm sorry. This needs to be dev xvda, and I want to grow partition number 1. Here we go. So it changed partition 1. The old size was this, and the new size is this. So if we call lsblock again, we now can see that it has, the partition has 50 gigabyte. So if we do df-ht again, we can see that our xvda, our root part, oh, it's still at 10 gigabytes. Why is that? Oh, we need to do df-h. Interesting. Interesting, because if I do lsblock, it shows me 50 gigabytes. Let's see. Let's just see if it works. I've lost my session again. Here we go. Okay, here we go. Okay. So now we do have a 50 gigabyte partition, and we should be able to deploy the Lambda function locally. Let's do that again real quick. Let's just run this again. Now it's going to build the image again. Yep. So it's going to fetch the base image. Time for me to have a drink. So as you just saw, what we can do is we can change the size of a drive on EC2 while the instance is running. So now I'm having the same issue. And that's probably because for some reason it still didn't realize that we resized. Let me see real quick. So yeah, that's fine. Let me see real quick. Now we need to troubleshoot. So our lsblock gives us 50 gigabyte. Our df-h only gives us 10 gigabyte. I'm not entirely sure why that is. Let's go back here to the documentation. Let me see. Okay. So we want this. What did we do? We had a look here. So we saw it's too small. We did this. Now we did X. Let me see. Yeah, so we did this as well. Sudo grow part def xvda-1. Okay, they still reflect the original volume size, which is the same here. Okay, to extend the file system on each volume, use the correct command for your file system as follows. I'll probably need to run this as well. Okay, so it did something. And if I call dfh again, now we've got the 50 gigabyte. I just forgot to do one step. All right, so now it works. We changed it to 50 gigabyte. So if we run this again, that should now actually deploy our container. And if you have any questions, please let me know in the chat. So what's happening here right now? I'm just going to explain a bit what's happening here. It takes the Lambda function that I wrote here, this very simple function. It fetches a baseline image for the Lambda function execution environment using the runtime that I chose, which is Python 3.9. It creates an image out of that base image, and the function, it's going to deploy it locally using a Docker container, and then it's going to run it using the run configuration that I have right here, including the payload that I've defined in here. So once that function has been run, we should get a result that includes this payload. So now it's mounting. And this took some time right now, but it only does that once because the whole fetching of the image of the base image and so forth only has to happen once. So let's see. Still mounting. Here we go. Okay, now next. All is done. Build succeeded. We've got the artifact. Now it's building the image. Yeah, it's running Python pip builder, so it needs to get all the dependencies and everything that I've stored somewhere. I don't have any dependencies right now. So it's doing all its work. And here we are. Here we are. So the Lambda function has been executed. The initialization of the Lambda function itself was just 1.14 milliseconds. The whole execution was this long, but that's just because it was executed for the first time. But we only have this. And that may be because my payload isn't set correctly. So it returned an empty object. Let me have a look here real quick. Okay, all right. So what I need to do as a payload is I need to add JSON here. And then inside of that, I've got my JSON object. Let's save that and just run it again. And now you can see everything runs much faster. It just needs to create a new image with the actual function code. It doesn't have to pull the entire Python image from ECR, from the container registry. So it's mounting everything, starting the application locally. Everything's running. And here we go. Now we actually have our payload here. We've got the test attribute and the test value. Cool. So the function itself works, and we can run it locally. So the next thing we want to do is inside of this function, we are getting, let's do that. So what do we get? Let me draw something real quick. As I said before, we have an S3 bucket, and we're uploading a file into the S3 bucket. That's a file with some statistics. And whenever this file gets uploaded, we want to start a process that then does something with that file. It's being triggered by an event, and this event is what's being sent here. So it's not the file that we get here. It is an event that contains information about the file. And with this information about the file, our Lambda function can figure out where is the actual file and then pull the actual file into the function to do something with it. Okay, so what we need to do here is get file location from event, load file from S3 because it's stored in S3, do something with file. Okay. So to get the file location from the event, we have to have a look at the actual event. And we can do that by having a look at our at the step functions state machine. Because inside of the state machine, whenever it's being executed, it hands over the information. So these are old executions. Actually, this is a new one. Actually, this is a new one because I uploaded something today just to test. However, what I'm going to do is, because the S3 bucket is empty right now, or should be. Okay, I've lost my session again. Here we go. It's I just got a new token. Let's see. Inside of S3, we have our video stat stack data bucket, and this bucket is empty. But now I'm going to upload a file, and I'm going to just use this file here. I'm going to upload it, and this should have triggered a step functions execution. So the next one should be at a different time. Let's see. Yeah. So this is the execution that has just been triggered through the upload. Now let's go into the execution. Scroll down a bit, and you can see what it did is it went through dispatch file, then it went through process YouTube file, and then it went through file upload processing succeeded and into the end. So this is supposed to be our Lambda function. Right now, as I said, it's only a placeholder, a past task. So it just takes the event and sends it further. But what we can do right now is have a look at the step input here. And this is the file, the JSON document that represents our event. And all we need is the bucket. We get that here, and the object name, which is this one. So what we need to take from the event is the detail. And inside of the detail, we need our, we can't even go here. We take our request parameters, and in here we have the bucket name, and in here we have the actual file name. So we can just take detail request parameters. Let's do that real quick. Bucket is event detail. Oh, let's do that first. Request parameters, event detail, request parameters. Here we go. And let's just return our request parameters. What I'm going to do now is I'll just pick this whole JSON file as it is. Let's just close that real quick. As it is, go here, add a new folder, test events. Let's call it test events. And I'm going to add a new file. Let's call it new put object YouTube.json. Open it and paste everything here. So here we go. We don't need all this in our test file. We also don't need the event version. We don't need the user identity. We can keep the event name. I don't need the user agent. I don't need the response elements. I don't need any additional data. Don't need any resources. Here we go. All right, so I'm just going to use this part. And now I'm going to copy this and edit it to our launch configuration. So instead of this, I'm going to add this. Here we go. So our payload contains a JSON document, which contains the detail and so forth. So let's save that. And just try running our Lambda function that takes the request parameters and returns them. Let's just click on run. Now here we go. All right. Now, if this works, the next thing we can do, and while it's running, I can already try doing that. The next thing we can do is say bucket request parameters bucket, and the file name request parameters key. There we go. Now let's see down here. All right, so here we have our request parameters. We have got the bucket name, so that's called bucket name. But the host, we don't need the host, but we do have our key, which is the actual file name. And so I don't, yeah. All right, so that works as expected. So what I'm doing here is I'm getting the bucket and I'm getting the file name. So now the next thing we want to do is we want to actually load the file into the Lambda function to be able to process it. And to do that, we need an S3 client or an S3 resource. And to do that, we are going to import Photo 3. And Boto3 is the Python SDK for Lambda. And once we've imported Boto3, what we can do is just say s3 equals Boto3 dot client s3. I don't want to use the client. I want to use the resource s3. And now let's have a look at the documentation. AWS Boto3 reference s3. So yes, I want to accept that. I'm going to resize it. And right here, you can see we do have S3. And inside of S3, we have, actually, we don't have a resource here. Oh, here it is. I was looking for R. We've got the service resource. So that's what I'm looking for. So S3 is Boto3 resource S3. And when we have the resource, we can get an actual object. And to get an object, we can just say S3 object, bucket name, and key. So our object is going to be this. And instead of the key, instead of the bucket name, I'm going to send it the bucket. And instead of the key, I'm going to send it the file name. And now let's have a look at the object. And I'll call it file. Let's have a look at the file. And once that's done, I will try things in a slightly different way to make it a little bit faster. I'm just going to use the Python REPL, the basically the command line tool where I can directly use commands to see the things. Because right now, every time I change something in the code file, it has to create a new Docker container, which then gets locally deployed. So that takes some time. But what we do have here is we've got an error message, unable to marshal response, because it would want to return a JSON object, but it cannot. So what I'm doing here is the following. I'm going to start a REPL. So let's say Python 3. Here we go. Now let's say import Boto3. So so we don't have a module named Boto. So I'm going to exit pip install Boto3. Let's do that real quick. Okay, cool. Now let's do that again. Python 3. I can't type. Python 3. So I'm going to say import Boto3. Now I'm going to say S3 is Boto3.resource S3. Okay. And now the next thing I'm going to do is do this. File is s3.object. And now we need the bucket name. Let's pull that from our test event real quick. The bucket name is this. And we need the key, which is this. And this is a file that actually exists because we've just uploaded it. So this is our file. And now let's say print file. And here you can see it's an object with a bucket name and a key. And let's say type file. Wasn't that type? it's of type Boto3 resources factory S3 object. Now, to actually get the file, we have to use the on the object, we have to use the get command, this one. So what I'm going to do now is file in memory is file.get. And this now will actually do an API call getting the file from S3. Now let's see. There we go. So now, okay, this is a response, but it contains the body of the file. Here we go. This is the actual body. And once we tried that, let's do it up here. So let's call the file is this one /get. And now we've got file.body. This one. And in here, we've got our actual file. We've got the actual data that we want to work with. And to do that, just real quick, let me see. Because I've got something here. All right, so what we can now do is the file body. From file body, we can say iter lines. So it's a file with multiple, I can open a file right quick to just have a look. This is our file. It's a CSV file. And with this CSV file, what I can now do really is in here, say iter lines. So go through it line by line. So I can do for line in, and now we've got our file body iter lines. Now do something with it. Let's say simply say print line. Now I'll do that down here just real quick. We've got our file in memory. Let's do for file in, well, I need file in memory. For, let's do that again. For line in file in memory. After that, I want the body attribute, the value of the body, and I'll say iter lines. Now let's see. Print line. There we go. So we've got all of our lines in here. Yeah, that's the entire file line by line. So what I can do here is I don't want to print the line. I want to add every line to an array. And to do that, I'm just going to say item is a line. And as you can see, it's encoded here. I can simply say line decode, because that's going to remove the B and the and these things, the quotes. I'm sorry, and the quotes. So I say a line decode. Item is a line decode, and then I say items equal items dot append line. And right here, I'm just going to give it an empty items. Yeah. Right here, I'm just going to create an empty list of items. And then I'm going to append them. And now let's just return the items. And that should be able to return the items as a JSON object. Now let's just have a look, run this. And it takes a minute again because it has to create a Docker image. And the result should be, once that's done, a list or an array of items. Now it's running. It's waiting for the SAM application to start. Here we go. All right. So as you can see here, we've got an array with a lot of items. Cool. And that's exactly what I was looking for. So we can let me see. Open the shell again real quick. So here we go. All right, cool. I need to source here. Okay, all right. So now we have all the items inside of the file. And what I want to do is, if we have a look at the items, the first thing I want to do is remove the first two, because this is just the header, the titles, the column headers, and this is just one line containing the totals. I'm not interested in that. I'm interested in all of those down to the bottom, except these two. So what I need to do here is, from the items, I only want everything from the third item up front. So I'll say items is, now I have to look it up. How do I get a range or just a part from an array? Python get part of array. How to slice. Oh, get array elements from index to end. Here we go. All right. So I can simply say, okay, 3. Okay, what does he want? He wants 1, 2, 3. But he wants from 4. So we started index 0, 1, 2, 3. So what I need to do is right here, items is items. And I want to start at index 2 to the end. I don't want the first 2, but I do want starting at B and H. Right? So what I'm going to do now is just test that real quick to make sure that I really have the one with B and H, and I'm not using this one, and I'm not missing this one. And that's a great answer. That actually helped me. So thank you so much. And thank you for the question. And I got a ton of points again. Anyway, all right. That's something that I really encourage you to do. If you use Stack Overflow, if you get answers on Stack Overflow that help you, to just upvote the answers and also the questions if they were good questions. Because people who do those, they do that in their free time. So, okay, so that didn't work. that didn't work. That actually returned an empty string. So items. Huh. Oh, I added the line instead of the item. That's my mistake. I actually added the line instead of the item. And I do need to add the item. And while that's running, I can already simplify this by just saying, append line decode. Okay, cool. And while that's running, let me just have another drink of water. And again, and again. All right, so what I'm going to do now, because for some reason that doesn't work, let's check in the REPL. Let's check in the REPL again. So what do we want to do? We want to start Python 3. Okay, import Bodo 3. And we need the resource. Then we need the file. The file is our object, and let me see the test setup from this bucket with this key. Okay. So dot. Let's get the file. Now we have the file. Let's say items is an empty array. Do that. Items. Ah, I got it. My mistake. This 0. I shouldn't put that 0. That's the mistake. So now, okay, items is, it's a typo. Items is this one. Okay, so now if I do print items, I've got the array. And it starts with, well, it doesn't show everything. But what I did here is instead of, yeah, I cut it. I said I want from index 2 0 items, and that was the mistake. So if I say items, let's say what's the length of our items? 105. And if I say items is items from the second index, and I say length items 0. What am I missing here? Ah, here, look at that. Look at that. That was a typo. All right, so let's do that again. Items is an empty array. I'll append all the lines. Now let's see len items. Because I did it already. So what I need to do first is really get the file again. Yeah, Here we go. So I need to get the file again because the iterator went through already. And now I need to say items. Hey, hey, Edwin, thanks for this message. Yes, right. And that's exactly what this is supposed to be. How it works in practice, not just a demo, but really how it works in practice, and also the struggling that you have and the things that you have to think through and things that you need to try. So that really is what I want to do here, really show you some real life examples. Milad, okay, so a question regarding the processing logic. Does it make sense to remove the file from the bucket after analyzing it? I mean, removing it here in Lambda? That really depends. I haven't decided on that yet, if I want to remove the file or if I want to move it into an archive folder maybe, or if I just want to leave it where it is. I just haven't decided on that yet. And that's a good point. That is something that we need to think about. Once we have processed the file, what do we do with it? So good. So we've got, but still, I'm trying to make this run. Using this. And now let's say len items. It's 114. And if I say len items to, that should be 112. And that doesn't work. Does that work? Oh, now again. Let's do that again. Len items to. Here we go. And that's 112. Yeah, I missed the closing bracket. Thanks, Milad. That's exactly the thing. So what I need to do here is I can't put a 0 in here. I need to do this. So items is items minus the first 2. Okay? Good. And so we loaded the file from S3. And now we're doing something with the file down here. Okay? So, and I'm just going to return the items. So I'm just going to pass the list of items out of the Lambda function. So we can remove this for now, the comments, we don't need them anymore. So all this Lambda function now does is it gets the file, extracts all the lines, line by line, puts them into an array, and then passes this array on to whatever wants to process it downstream. So I'm just going to run it again real quick to make sure it works before I deploy it. And while that's running, I'm going to take a quick bio break, and this is your chance to take one too. I'll be right back. All right, I'm back. Well, for everybody who just joined the stream, welcome. My name is Dennis. I'm a developer advocate. I work at Amazon Web Services. And today we're live coding an application. We're building an application using AWS services in general. And what I've done right now is I created a Lambda function that extracts some data from a file, from a CSV file. And I just ran it locally. I tested it locally. And in fact, it returns an array of entries. And the first of which is B&H. Let's have a look at the file itself. The first of which is B&H. All right, so cool. That seems to work. That's our Lambda function. And what I'm going to do now is really just deploy this Lambda function as it is to AWS. And if I go back to the Lambda console, you can see the function here, and it is still empty. So here it doesn't do anything except just return the event. And once I say CDK, let's see first if it's going to change anything. CDK Diff. All right. Okay, so we've got some stuff that is changing. And it's mostly a lot of asset parameters for the deployment itself. And the function is being changed. And that's about it. So let's CDK deploy. So now it's creating the CloudFormation change set. And once that's done, it's going to run the update CloudFormation API call. Here we go, update in progress, the video stats stack. And then it's going to update the Lambda function. This just takes a second because it has to upload the actual assets, the actual code to S3, and then it's going to deploy the function from S3. Here we go. Now update in progress for the Lambda function. And once that's done, we can go in here, reload the Lambda function, and we can see down here, we've got our actual function code in here. So the only thing missing is our step function state machine. Let's go back to that one. Our step function state machine doesn't actually use the Lambda function. To do that, we have to go back to our stack, into the state machine definition, and add the function to the state machine definition. So what I'm going to do is I'm going to just move this up here, because that somehow needs to know about the function. And I'm just going to give it the Lambda function. Let's go to process new file state machine. That is, let me see. Here's the state machine. This is my process new file state machine. And what I want to do is, what I'm using right now, process YouTube file, right now is just a task of type pass. It's just a placeholder. So what I want to do here is replace this with an actual Lambda invocation. Jonathan, good to see you. Thanks for joining. Have fun. Have a nice weekend. I see you next time. Take care. So, yeah, so what I'm going to do now is I'll just extract this pass function into its own variable. So I'll call it placeholder and put placeholder here. So this is the placeholder, and I want to replace the placeholder with an actual function invocation. Because if we look at the step functions here, this one, right now, it's just a placeholder. Right now, it's not an actual function invocation. So how can we do that? How can we add an actual function invocation as a task? Let's have a look at the documentation. Right here, we have the CDK step functions. And inside of the step functions, we have the state machine. That's what we're working with. But what I'm looking for really is step functions tasks. And inside of the step functions tasks, we should have something with a lambda. Let's search. We've got the lambda invoke task right here. We've got a lambda invoke task, and that takes a number of things, including a lambda function. Let's go back up. Oh, come on. Let's go back up to the package overview and see if we find a code example. Here we go. So, and that's it. That's all we need. We need a lambda invoke, which takes the context, the scope again, an ID, the function, and the actual input path, which means which part of the input do I actually want to hand over to the lambda function. So all we need to do is import this package, which is step functions tasks. Let's do that up here. Step functions tasks as tasks. And instead of paths, we simply say lambda function is tasks invoke function, invoke lambda. Look again real quick. Lambda invoke, it's lambda invoke. Self. Let's call it, what do we call it? File, process YouTube file, and just give it the same name. And right here, I need the scope, should be self. I'll give it the same ID. And then I need the lambda function. And that's my function. And since I'm not using an input path, I don't think I need to use it. Let me see. We've got the lambda invoke. And lambda invoke takes the function, the client payload, the qualifier, what was it? Command input path. And that's optional. So I don't need to use that. I can just use it like this. I'm going to remove the placeholder. Let's go back here and have a look at our step function state machine. Definition right here, right now. This is just a pass state. And once I deploy this, it should, oh, okay. Oh, I don't have that. So I also need to add that to my requirements. Okay, I got something wrong. AWS step functions tasks. Do I have a typo? AWS step functions tasks. Huh. Hmm. What am I missing? So let's see. Cannot import name AWS step functions tasks from AWS CDK. I'll remove that. I'll have a different error because it doesn't have tasks. Yes, tasks is not defined. So again, AWS step functions tasks as tasks. Am I missing something here? Oh. Forgot installing the requirements. Because I added it to the requirements, but I didn't install. I didn't pull the dependencies. All right, so now again, CDK deploy. And it has no placeholder. I still have the placeholder somewhere. Yeah, here we go. I want to add the Lambda function instead of the placeholder. Here we go. All right. Yeah, Edwin, that's exactly what I missed. Thank you so much. Okay, Lambda function. Okay, all right. I shouldn't use that because I'm using it here. That's the mistake. And now it should, theoretically, should work. Yes, it does. All right. So we do have permission changes again. So it asks us if we're fine with that. So we're adding invoke function to the state machine. So our state machine should now be allowed to invoke the function. And while that's deploying, just real quick, okay, so I've got to, give me a second, recreate the session. Here we go. Here we go. All right. So it's connected again. And it's deploying everything. And while it's deploying, let me pull up my drawing board real quick. So what we have right now in our, we have our step function state machine. This is our start. Then we have our, I'll do it differently. We have our start. Then we have a choice. And if it's a YouTube file, go here. If not, go down. And this here was a simple place. Oh, all right. This here was a simple placeholder, and we're now replacing this with an actual Lambda function, right? And everything is done. So let's have a look at our step functions console and the state machine definition. And as you can see here, now it uses a type, process YouTube file. This time is of type task. It uses Lambda invoke with this Lambda function. So what should happen when I upload that file? We should get a new execution. So not this one, not the 91. Let me upload the file again. I'll delete it. Yeah, I need to reload the session. All right, so now it's getting all the data. It's connecting to Europe. Here we go. We've got S3. We've got our data bucket. I'm going to delete this file. And I'm just going to upload it again. Video stats, data, YouTube CSV. Upload. So that's done. And now we should have a new execution. It shouldn't start with 9.1. Here we go. So this execution failed for whatever reason. Let's have a look. It failed. It failed in here. So why did it fail? It has an access denied when calling the get object operation because the Lambda function doesn't have the permission to actually get the file from S3. As you know, in AWS, everything needs to be explicitly permitted, otherwise it won't work. And to add this permission, what we now have to do is in our stack, using the grant method, the bucket, because this Lambda function should be able to read a file from this bucket, we can simply say bucket grant. And now let's have a look at the documentation. AWS CDK Python reference grant S3. Let's start with S3. Python. Okay, so to grant, we want to, where's the bucket? Here's the bucket. To grant access to the bucket, we can say, where is it? Down here, add, oh, let me search. Here we go. We can grant delete, grant public access, grant put ACL, grant read. We want to grant read access. So what I'm just going to do here is say grant read, bucket.grant read. Now I'm just going to give it the Lambda function. And with this, we are adding permissions for the bucket, to the bucket policy, so that the Lambda function can actually access it. Let's have a look. CDK, if I say CDK Diff, that now should show me some permission changes. And here we go. So now we're allowing the Lambda function to do get bucket, get object, and list on our data bucket. If we go here, I'm going to reload that. If we go here and have a look at the Lambda function's permissions right here, we can see all it can do right now is do stuff with CloudWatch, so write logs. And now I'm going to deploy this, CDK deploy. Yes, I want to deploy the permission changes. So what it's going to change is add a policy and add the policy to the Lambda function's execution role. No, that's not right. Oh, it is right. It does add the policy to the execution role. So video stat stack is being updated. Next, it should update the Lambda function. So I set that the wrong way around. It's not adding a bucket permission. It's adding the permission to the Lambda function's invocation execution role. So it's changing the default policy. And once the default policy has been changed, it's not changing, it's creating that default policy. And once that's been created, it's going to be added to the function. And now that it's done, if we reload the function permissions, you can see now that it also has permissions on S3. And in this case, it's able to do get object, get bucket, and list on the bucket itself and on all objects inside of the bucket. So now let's upload the file again. I'm going to delete this, delete. I'm going to upload. And now let's see if we have a new execution. We do have a new execution, and this time the execution succeeded. If we look at the execution, you can see it went into dispatch file. Out of the dispatch file came our event. Then we had our process YouTube file that took our event, and the output of the process YouTube file Lambda function actually is our list of entries. Plus some data, plus some SDK HTTP metadata. But that's basically the payload that's coming out of the Lambda function. So the Lambda function does what it's supposed to do. Now I could add something downstream to process all these lines. For instance, in parallel, I might want to do parallel processing with each of these lines. And I could do that using the state machine. But in this case, what I'm actually going to do is I don't only want to just hand down all those lines. I want to extract the data inside of the lines, because that's still a CSV. Each of these lines is a comma separated line, and I want to extract the actual data from that to then write it into DynamoDB. And this is something that we're going to do in the next stream, because it's 10 to the hour right now. We're almost 2 hours in. It has been a lot of material. I'm just going to recap real quick what we did. So we had, in the beginning, we had our step function state machine that just used the placeholder. And it had a choice before and so forth, but that doesn't matter. That just had a placeholder. And what we did now is we created a Lambda function using CDK. We enabled our system to test it locally. And once that works, we're using the CDK to deploy the Lambda function into the state machine. And the code we used is in here. Let's see. We can use the final minutes to do a little bit of cleaning up. So what we're doing here is we're creating the Lambda function. And I would want to refactor that into its own file. So simply say process YouTube statistics file. The process YouTube statistics is, and now I'm going to use the pattern that I used for the other ones. And I'm just kind of going to call Lambda, I'll call it process YouTube statistics function dot create, give it myself and the name. So what I'm doing right now is I'm refactoring this into its own function, or rather into a class containing this function as a static function. So I'm going to do this, and I'm going to create a new file. Let's call it file processing. We'll put it into file processing, new file, process YouTube statistics.py. Simply say class on. We want the class to be called, I remove that and remove that. The class to be called process YouTube statistics function. And inside of this class, I want a static method, def create. And inside of that, I want to do this. So what does it need? It needs the scope, this one. It needs the ID. There we go. Does it need anything else? No, it doesn't. So what we do here is we create a Lambda function using this pattern. This needs to be renamed. And this needs to be renamed. Let's see if it works or if I made any mistakes. I did make a mistake because I forgot to import this. Don't need the core. And over here, I don't need this anymore. So let's do CDK Diff. Shouldn't be any differences. It should compile first. And second, there shouldn't be any differences. So it doesn't compile because I didn't import it up here. So we also need to add from file processing, and we called it process YouTube statistics. There we go, import, and we're going to import this. Let's try again. Okay, another error because undefined. All right, because we're not returning it, I need to return it. I made that mistake last time as well. Okay, so I need to return it, the resource, otherwise it wouldn't construct it. Okay, return Lambda function, and that doesn't make any sense. I need to return it like this. And that's just some refactoring right now to make sure everything's clean and everything's readable. It worked, and there are no differences. So right now in here, you can see what we're doing. We're creating the bucket and the trail for monitoring and data upload. We're creating the function. We're granting read access to the function. And I would like to add that to the function itself. So what I'm going to do here is just add the bucket and go inside the function and let's see, we'll do a function is, is this one. Call that function return function. And we also need the bucket up here because we're going to grant read access to the bucket for the function. So let's do a CDK diff again. There shouldn't be any differences. No differences. Great. So that's our function. And then we have the state machine, which processes the new files. And to be honest, I would like to define this function inside of the state machine because it's part of the state machine. I don't want to define it externally from the state machine. So let's go to that. We can close this. Process new file state machine. That's this one. Huh. Yeah, that's where we're getting the function. And I don't want to get the function. I want to create it in here. All right, so we have process YouTube statistics. We're going to remove the parameter. Process YouTube statistics. Add it here. And that means we need to import it. And see if everything still works. Let me see. The state machine. I'm not going to add that here anymore. Check for differences. See if it compiles. It doesn't. Right, because I can't use self over here. I need to give it the scope. Because I've got self here, but since I'm doing everything inside of this, I need to hand it the scope. Now the bucket is missing. Now we need to hand over the bucket to the state machine. The state machine takes the bucket and hands it over to our Lambda function. Cool. So there were no differences. Everything compiles. So what we're doing now is we are creating the Lambda function that the state machine uses inside of the state machine definition. It doesn't clutter down out here. So this looks good. It's clean. That's from a very abstract perspective. That is what we have. We've got the bucket and the trail. We also might refactor that into one thing because the trail belongs to the bucket because it's the monitoring of the bucket. But I might do that next time. So what we have is the bucket, the monitoring of the bucket, the object put object rule that triggers the state machine, and everything that the state machine does is inside of the state machine. And this could use some cleaning up as well. But looking at the time is it is at the top of the hour. Thank you so much for watching. It was a lot of fun. Some things didn't work as I wanted them to, but eventually we got everything to work. I hope you were able to learn something new. I'm just going to remove the screen sharing here. Hope you were able to learn something new. Thank you so much for watching. I hope, yeah, as I said, I hope you were able to learn something. I'm going to broadcast again next week. And don't forget, the week after next, if you're looking at this right now, the week after next is reInvent. And I'm not going to broadcast during reInvent. However, I'm going to be here next week and then 2 weeks after that. Take care. Goodbye.